Hello, everybody. So, welcome back to the video. This is a part two of the EDA. So, for today's EDA, we'll be doing the product categories of gets data. I will add this to the description. So let's get started. We will be covering just a quick exploration. Let's start off with just importing, and then I made the code. The code will be attached in the description. So the head, as you can see, we have the RFx ID. It seems familiar. We've used it in the previous EDA. It's a system defined record, which is a I'm guessing this is a foreign key, which and in the other, it can be used as a foreign key. As the other table, it's unique identifier as well. So we can use it to link up between the two tables. But let's talk about that later. Now, once we loaded this, we can notice that the UNSPSC classification, it seems like it's a float value. So we'll need to change that into an integer value. And then we also have the UNSPC description, and the description, which is the building and facilities. Like, for example, it's the specific description to the code. Both of them are unique. We'll talk about that later. We also did bottom 10 as well. That's the tail 10. And we have different categories. Some are slightly vague, like antiviral drugs, and also we have this is just a random sample of 20 categories. We have truck, tractors, economics, very vague, but we'll see what maps to it once we merge it in the next video. Now we have our RFX ID is integer 64. In the previous video it was float, so we'll need to change it accordingly later on when we merge it. And also the UNSP classification float. We also have an object, and the date. I'm not really interested in merging the report date because it's also there uh, in the other data set. And moving on to, let's get started on the observation. Let's see what is the columns and what are their descriptions. I've made a very simple description here just to make it easy for the future video, which is the UNSP different types. So tender identifier, links to award, it's a foreign key. We merge it with award notice dataset, and these are the other description for each column. Now, for the dimensions for this data set is 29,000 rows, and it's four columns as we saw just now. And we have RFX IDs of 16,000, which are unique. But also there are times when the RFX IDs are repeated, and as you can see, and when it's repeated because it needs to map to other codes and description, because one RFX ID can have many, which means that it's a one-to-many relationship. And For the missing values, we can have a look at what are we missing. For the UNFSC classification code, we have 801 missing rows, and we also have 600 missing rows for the description. Now, we'll talk about that in the coming section. For the RFX ID analysis, I just did a simple analysis, or we just observed that how many times are they repeated or they're linked. For example, here we have the mean of one, and per category, so one RFX ID per category. But sometimes we have a max of 126. This can be an outlier, as and it's a multi-label data set. So this is extremely unusual for the 126. And we have here we have some visualizations. As you can see, it is mostly mapped to the one category, and yeah, and there are some cases where it's mapped to one RFx ID mapped to almost 15 categories and so on. So we have here we have the cumulative distribution. This is in case we want to remove any number of categories that are mapped to that specific RFx ID. Then for our models to make an accurate prediction, then we did this cumulative distribution. So we start off with just uh, one RFX ID means one RFX ID mapped to one category makes up to uh, maps to one to one. It's 69. Yeah, it's 69%. But then maps to two, then it goes up to almost nine. If we move to three categories, it's almost 90 percent of the data set. So means that we can just adjust it based on the number of categories later on for our model training or whatever model that we will be deciding. Now for the UNSP classification codes, we are just seeing that it's unique codes, 1.2K unique codes. We also have, as I mentioned, 801 missing codes. Now, the code is laid out from this 1 million to 100 million. I think that is three, six zeros, and that's 10 million. And then this is 95 million. This is the minimum and maximum. So it means that we have a code range, and then we also have it's consistent 8 digits. And the one that is who struck me, the interesting one is that I took the most common codes here, and as you can see, for this code, 72 million is mentioned 6,000 times, so 22%. And we also for here like building facility maintenance and services. So as you can see, it's over samples, so it can be that it will possess a bias if we were to use traditional models like logistic regression or decision tree. So either we use different sampling techniques to balance it, or we use a model that is not so susceptible to bias distribution. So I was thinking of going with the later, because since we are using in the future we're using embedded models and vector search. We will be vector search requires a lot of information, and it performs best with a lot of information. So I will keep it. And now for the UNSP description, we have the description analysis. We have multiple types of description here, and we have 1236. This is almost the same as the code itself, and yeah. So as you can see, these are similar to what is we have spoken earlier. And here I just did a simple code versus descriptions. And here is the advantages. And also over here for the code range, I dropped the missing values, so which are the 801, which brought it down to 28203. And by dropping that, it also made the description zero missing values, as you can see, because the description is tied to the classification code, UNSP classification code. Now, moving on to the description, the codes and description comparison. We have they are one-to-one mapping. So for each code, it has a unique description. And I just did a simple memory comparison. So just to decide what to use in the future for our model, it seems like the codes is more lower on the memory. So that means it can we can train it quickly. Now, it's so here I just put a text where what is the advantages of using just a normal description mapping. There is the simple the code. The code is easier for processing, compact, and so on in terms of that. But for description, it's human readable and it's very simple to understand. But fear no, but then we can use it in Gradio to map the once we get the code, and then we can map it to the description to the front end. So no problem. We and for the code description lookup, we have different types of code description. And yeah, it's a very simple. This is a very simple EDA. We are just exploring the different types of multi-labels here. So you can see here the RFx ID. Uh, Remember when I said one to many? So here we have this RFx ID. It's mapped to here is building, facility, engineering, research, and land and building structure. So what this means is that we should use a model that gets a top number of lookups for the similar codes for material codes instead of just giving one single material code, because there are cases where they need more than one categories. So now moving on to the percentage of how many codes that are individual codes. We have single labels is here, and multi-label is here. So it's almost three quarters, 67% and 32%. And this is a very familiar diagram we used previously. And yeah, so that is about it. It's a very quick EDA. And let's move to merging the tables. See you soon.